This is Laura Duncan from CSMS. Today we'll be solving using the quadratic formula again. To review, using the quadratic formula, we'll put the equations into standard quadratic form. Find your A, B, and C and carefully substitute into the quadratic formula. Then you'll solve. One thing that we need to remember is the square root of a negative will give you no solution. Solve each equation using the quadratic formula. Round answers to the nearest tenth. Let's look at number 1 first. Notice that it is not in standard form. So to put it in standard form, we'll subtract 6 from each side. So we'll have 3n squared minus 2n minus 6 equals 0. Now that it's in standard form, we can find our a, which is the coefficient in front of n squared, our b, which is the coefficient in front of n, and our c, which is negative 6. We'll substitute that into the quadratic equation. X is equal to the opposite of b plus or minus the square root of b squared. Be sure to put that squared in parentheses, minus 4ac all over 2a. So now we're going to solve underneath the radical. Now I'm going to change this x back to n because according to our equation, that's what we were looking for, n. Now we found that under the radical is 76, so we'll have 2 plus the square root of 76 over 6, and 2 minus the square root of 76 over 6. That will give us our two solutions. So one solution is 1.8 and the other solution is negative 1.1. Those are our two solutions. Now let's look at number 2. Number 2, we need to make sure everything is equal to 0. So to do that, we'll subtract 16x and add 2x squared to both sides. That way, it will all be equal to 0. So let me rearrange this so that my x squared is first, followed by my x, and then followed by the constant. It's all equal to 0. Then my a is 2, my b is negative 16, and my c is 32. Please pause the video here as you substitute a, b, and c into the quadratic formula. Once we substitute and we solve underneath the radical, we see that we have 16 plus or minus the square root of 0 over 4. Well, when we have 16 plus the square root of 0, which is equal to 0, divided by 4, the solution will be 4. And if we have 16 minus the square root of 0, which is 0, then the solution will be 4. This is one of the cases where we just have one solution to this quadratic equation. That gives us 3 possibilities for solutions. In this case, there's only one solution. In the case at the beginning, we can have no solution if we have a negative square root. And in most cases, like number 1, we will have 2 solutions to a quadratic equation. Let's go down to number 3. In this case, we have fractions. So to get it into standard form, we are going to multiply each term by the least common denominator. Since we have a 2 and a 3, the least common denominator would be 6. And we're going to multiply 6 by each term. 6 times 2c squared would be 12c squared. And then 6 times 1/2 c would leave us with 3c. And then finally 6 times 2/3 would give us a product of 4. Now that it's in standard form, we see that our A is 12, our B is 3, and our C is 4. Please pause the video here while you substitute that into the quadratic formula. After substituting, we have C is equal to -3 plus or minus -183, the square root of -183 over 24. Since we have a negative number underneath the radical, that will give us an error. And that leads us to the fact that there is no solution in this case. So please box your answer. Now let's look at some application problems. The drawing below represents the path of an object that is thrown into the air. This drawing represents what a quadratic equation looks like. Now in number 4 it says the path of the ball that is thrown upwards can be described by the equation h equals 35t minus 5t squared, where h is the height of the ball in meters and t is the time in seconds. Letter A asks, how high is the ball after 3 seconds? Well, when we're talking about 3 seconds, that is obviously talking about time, and it's saying that the time is equal to 3. Well, in this case, we would simply take the formula, h equals 35t minus 5t squared, and we'll substitute t equals 3, and we'll solve for h. So we have a time of 3 seconds. Please show all this lovely work of what you're putting into your calculator, and we find that the height is 60. And since we're talking about meters, our solution will be 60 meters. For part B, it says after how many seconds will the ball be 50 meters high? Well, that implies that the height is equal to 50. So let's substitute that into the given equation. Then we can either factor or set this up so that we can use the quadratic equation. In any case, let's put this into standard form so that this side will equal 0, which is what we want. And to put it in standard form order, we'll have our t squared first, then our t, and then our constant. Now if we use the quadratic formula, we'll have a is equal to 5, b equals -35, and c is equal to 50. Please pause the video here and substitute a, b, and c into the quadratic formula. Now we have t equals 35 plus or minus the square root of 225 over 10. That's a perfect square. So 35 plus the square root of 225, which is 15 over 10, will give us a solution of 5. And then 35 minus 15 over 10 will give us a solution of 2. So after how many seconds will the ball be 50 meters high? Well, there's 2 answers to this. It will be 50 meters high after 2 seconds and after 5 seconds. So let's look back at our picture to look and see why that could happen. Since this is the distance or the height, let's pretend that this is the height. The height right here is equal to 50 meters. So that would happen when x is equal to 2 and when x is equal to 5. That's very helpful when we're looking at letter C. When will the ball hit the ground? Well, when it hits the ground, the height is equal to 0. Looking back at the picture, where is the height 0? Right here. So it appears that there would be 2 answers. So let's take a look at this. When h is equal to 0, we will simply substitute that in to our formula. So 0 equals 35t minus 5t squared. Let's get this into standard form so that we have a positive 5t squared. And what we do to one side, we'll do to the other. So we would end up with 5t squared minus 35t equals 0. Now you could use the quadratic formula, but looking at this, it would be easier to find the GCF. Once we find the GCF of 5t, we would be left with t minus 7 times 5t equals 0. Now we've factored it, so we'll have 5t equals 0. We'll make each of the factors equal to 0, and then we'll solve. So this gives us a solution of t equals 0, and then a second solution of t equals 7. Now let's think about this. Let's go back to our picture. The question was, when does the ball hit the ground? Well, if t equals 0, that is where we start. So it doesn't hit the ground at 0, that's where it begins. So that eliminates this as an answer. The ball hits the ground when the time is 7 seconds. That concludes your lesson for today.